Hi, I'm Oliver Gao. I'm the director of Cornell Systems Engineering Program. I have been fortunate to conduct these what I call system conversations with our prestigious speakers that we bring to Cornell to talk about our system challenges as well as system solutions. Today, I'm very delighted and honored to have Dr. Dooley Rosenberg with us. Dooley is a senior economist at the World Bank, and her work includes green growth and climate change mitigation strategies, as well as climate change adaptation and a disaster risk management. So you can see that this is really a very broad spectrum of issues, but I feel it's kind of classed together through the infrastructure systems. So actually, Julia got her degree, I believe, college degree in engineering, and then she moved on to get her PhD in economics. That's quite a stride out of engineer and go into economics, and both from I believe the university in Paris. I think the undergrad degree was from École Nationale Supérieure de Techniques Advances, and a PhD in economics from École des Hautes. Maybe you can help me pronounce that.
Oh, EHESS is it's a social science school, basically.
Social science group. Yeah. Wonderful. Thank you for taking time to visit us. I was looking at your bio and also your research work. That definitely doesn't belong to a traditional engineer or a traditional economist.
No.
So this is really impressive. So because of that, I'm very curious in learning more about you yourself, your career, and how all these things evolved to today where you are.
Okay, well, thank you very much for the invitation. I'm really glad to be here too, and to be able to speak with the faculty and give this seminar. So indeed, I started with engineering, and I was actually specialized in environmental engineering.
Oh.
I knew I wanted to work on climate change issues, and at first I wanted to work on the climate science aspects of things. But then I had the opportunity to do an internship after my first year of master's. I did an internship in this research center in Paris that is more of an economics research center, where it's a lot of engineers because they do integrated assessment modeling. And so it's energy system modeling coupled with economic models to understand long-term transitions for climate change mitigation. And I did an internship there. I really enjoyed it, and that's when I decided that after my engineering degree I would shift towards more economics. And so I took some classes in economics, and then I did my PhD in that research center, focusing on modeling for long-term mitigation.
Long-term mitigation.
Yeah. And the focus of my PhD was how can we use these big complicated models. Those integrated assessment models have been very criticized because they're big computational models that require a lot of assumptions that are used to make simulations over 50 or 100 years, and that are not necessarily very robust in the kind of in the results that they give. But so my focus was on the uncertainty and on how to bring robustness when we use these models. And so I started using those robust decision-making techniques that were developed by Robert Lempert at Rand Corporation, for example, and others. And I use RDM to get robust results from those big, complicated, integrated assessment models. That was the big idea. And after that, I got the opportunity to work as a consultant for the World Bank because they wanted to do a report for which they needed a modeler. And there I started working on a completely different topic, which was, not completely different, but which was on the impacts of climate change. So a lot of it is through engineering as well, but a big part of the focus was also on the impacts of climate change on poverty. Because we had some evidence that poor people are the ones that are going to be the most affected by climate change impacts. But if you look at most of the economic analysis that had been done or the assessments on climate change costs, they're all at the macroeconomic level, and they never capture the impact on the poor, just because the poor have so few assets that in economic numbers they never appear. So then I started a whole new research program, which was on quantifying the impacts of climate change on the poor, and also on how to prioritize investments in resilience and adaptation, taking into account the impact on the most vulnerable. And same there, it was about creating new economics tool, new modeling tools for decision making, to incorporate the welfare impacts of disasters and climate change. So I'm still really interested in long-term climate change mitigation. But it is true that recently I have focused a lot on resilience through engineering infrastructure systems and also through the more social and social impacts.
Yeah, that's that aspect when you speak of resilience, that social aspect somehow could be kind of ignored, while a lot of engineers are focusing on how can I make this structure more resilient? Yeah. So, well, that's wonderful. Thank you for kind of going through. Now I can see that all these different dots actually now connect very nicely. Yeah. When I look at the work you are doing now, you started with as environmental engineer, and it actually seemed like that intern played a very significant role, kind of exposing you to this kind of integrated.
Yes.
I think it's probably now I was at Michigan 2 weeks ago at a sustainability conference, and I noticed actually among environmental engineers and sustainability researchers seem like I think it's kind of you mentioned long-term systems approach seem to be kind of more appreciated and valued.
Yes.
Yes. So I think you're concerned about environment and you're concerned about climate change, and of course you work out different both from mostly kind of economic aspects, of course based on the analytical result of those engineering quantification, and then you look at both at a higher level and also probably at the community level when we look at like equity issues. Yeah. So while you are driven by these kind of environmental climate concerns, but apparently now a lot of work you are doing is actually focused on infrastructure. Yeah. So I myself, because I was trained as a civil engineer, but also with a dual degree in environmental science. And I had the same concern as you had. I was concerned about environment, but then kind of that actually in the end kind of drove me to transportation and infrastructure, somehow similar to yours. So I was curious. So I want to ask, why infrastructure? Why infrastructure now becomes, the key focus that you are trying to work on, with hopefully the purpose of addressing your initial concerns related to environment and climate and even equity issues. How is infrastructure system connected to those performance measures that you're concerned about?
Well, on the infrastructure in general is key to sustainability. On the one hand, on the climate mitigation side, one of the robust results that we get from the IPCC and from those integrated assessment models is that in order to mitigate climate change, we need to reach net zero emissions sometime before the end of the century. And a lot of the work to reach net zero emission is to have a zero carbon electricity system and then to electrify the transportation system and some of the end use industry uses. So a lot of the work, especially in the short term, is on the electricity system and the transportation system. And how do we make sure that all the new investments that are happening right now, and there's a lot of investments happening, especially in the developing world, in infrastructure, are consistent with this long-term view of a zero carbon energy system and transport system. And so it's understanding how to prevent lock-ins, how to prevent stranded assets. For example, a lot of countries today are still investing in coal power plants. But now the price of renewable energy keeps going down, And it's not crazy to say that in 5 to 10 years, a fully renewable electricity system will be cheaper than one based on coal and gas.
Mm-hmm.
So all these countries that are investing now in new coal power plants, how risky are these investments? Will they have to strand all these assets soon to switch to renewables? Can we help them do better planning to take this uncertainty into account, see the long term, and make sure that they're prepared now for a low carbon system?
Yes.
And I think electricity is easy. Transport is a bit more complicated, the electrification of the transport system. It rests a lot on using public transportation, which are extremely expensive investments. Although now a lot of cities are investing in bus rapid transit systems, those could be made electric fairly easily. And a big issue is also the last mile problem. How do you bring people to the public transit system in a way that's also low carbon and sustainable?
Mm-hmm.
So all of these are fascinating research questions.
Yes, they are. Yes, they are. And Julie, I really appreciate that you when you answer my question. I think you pointed out immediately. You said that infrastructure is a key, and I totally agree with you. One thing is that infrastructure is a key not only because it's huge investment, it's huge size, right? But also, one thing that I noticed that infrastructure, of course, infrastructure investment is irreversible.
Exactly.
Right.
Yes.
And after you invest, whether right or wrong, it's very hard for you to reverse it.
Yeah.
That's the first thing. And the second thing is that after the infrastructure is constructed, and people are going to live in that infrastructure. So as a result, an infrastructure will shape the behavior of human beings, right? So one thing, and you mentioned like developing countries like India and China, the whole world saw that these developing countries, like BRICS countries, right? So they enjoyed so much development, especially in infrastructure development. So in the past 2 or 3 decades, look what happened in China and India. But in the meantime, you can see that while they have extended miles of roads and rails, but the congestion level
is still very high.
It's still high and even increasing, and not to mention the air pollution in the winter time. You can see that now people did not seem to praise that, oh wow, now I'm enjoying this improved traffic. Instead, they're complaining about congestion and this kind of dirty air quality. So in that sense, we cannot help asking, why did we invest in this infrastructure? Did we invest this infrastructure to invite complaints about congestion and air pollution, or what is the purpose of this huge infrastructure investment? Is our purpose wrong, or was our approach wrong?
So I think to come back to the irreversibility point, I think that's how I start all my presentations. And
wow.
my first slide is always, okay, countries are investing actually more than $1 trillion every year in infrastructure, and those are all irreversible choices. So how do we help them today with the tools that are required to make the right choices, to avoid that in 20, 50 years from now, they end up in very costly situations. On the why are we making all these investments, I mean, the literature on this is all over the place. There's of course a strong correlation between infrastructure and economic growth. Infrastructure is necessary for economic growth, so that's one of the main reasons why we do it. But then it's not always very efficient. There are tons of examples of highways that have been constructed in China in particular, but in other countries as well, where there's no traffic, and on the other hand, areas where it's always congested. And did we maybe underestimate the size of the system that needed to be built? And there are, if you take individual infrastructure projects, It could be political reasons behind them.
Absolutely.
There are many reasons why some infrastructure projects are built that are not always based on efficiency or even social considerations. In general, countries are learning also as they're doing all these investments. They probably need more prospective tools to understand the long-term consequences of all these choices, or even the mid-term consequences. But I would say they need to keep investing, right? Those investments are going to happen. They probably need to increase even more because the development community has those sustainable development goals. A lot of these goals, 7 of them, are related to infrastructure. It's universal access to clean electricity, universal access to safe water and sanitation services. Some of them are on sustainable urban transport infrastructure. Because infrastructure services are also key to development.
True. Yeah.
So now the big question is, how do we make them sustainable? How do we make them at the service of everyone and not the richest, not just the richest? And how do we make sure they're resilient to future climate change impacts as well?
Yes. Yeah. I think of course, I believe we believe that kind of investment in infrastructure, is the right thing to do. But how can we do it right? That seems to be
the main question.
That seems to be the main question. At least from what we observe, some countries seem like something was not carried out, in the right way. As a result, right? So there were those kind of unintended consequences that are could cost more than infrastructure investment itself, like cleaning up the air quality. That's such a huge kind of endeavor for people to do. That's actually why I think kind of naturally led me to my next question. I really pretty like in your abstract, you are saying that we want it's no longer for infrastructure investment. It's no longer just simply focus on spending more, but spending in a better way, in a smarter way. Yes. I want to kind of to see if you can expand that point. I feel that's such a nice point.
Yeah. Well, there are many different levels at which we need to be spending better on infrastructure. One of it is on the whole planning side of things. It's what I was discussing before. It's making sure that we take the long-term conditions or the long-term consequences of the investment into account when we're designing and planning for infrastructure today.
Yes.
And that's where the whole robust decision-making approach, I think, is key, because it's about exploring all the different future scenarios we can think of and analyze how the decisions we're making today will play out in all these different futures to make sure we avoid catastrophic consequences of our choices. And that, with climate change and the big uncertainty around climate change, is central to the decisions we're making today. So that's one, is on the planning. Another one is actually on the whole governance, procurement, corruption. Right now, the process through which those investments are made are extremely inefficient and costly. It's not unusual to see a very good plan result in a very poor investment just because money was lost along the way, God knows where, to corruption, or people decided to make some cut here and there, and the final quality of the infrastructure piece is actually lower than what was decided at the beginning. That we see all the time. Also, in many countries, there is no competition in the construction industry, so unit costs of building infrastructure are very high, which also creates a lot of problems for public budgets because they have limited budgets for infrastructure. So that's another place where there should be better spending. And then the third one is on maintenance. we have done a study, and actually 2 studies, where we show that $1 spent in maintenance of the infrastructure is worth $1.5 in new investments. And yet, right now, in a lot of countries everywhere, there's very poor maintenance of infrastructure systems. And that contributes to a lack of reliability of the systems, to a lack of resilience as well. And it increases overall costs, because then, so it increases the cost for the users, of course, but also for the public budgets, because they have to rebuild more frequently that same infrastructure. Mm-hmm. And so on the spending better aspects, there's a lot of progress that has to be done on the sustainability of budgets for maintenance of the infrastructure.
Wonderful. Apparently, I think you pointed out all these key, I wouldn't call it failures, but key factors that are underlying the non-ideal performance of the different sectors in our decision making, right? So for this thing, of course, as concerned researchers or scientists, like you have devoted your career, helping to drive things towards like a better place, and with better planning, with longer term views incorporated. So now I want to kind of dive a little bit deeper for us to. So from your point of view, I think I really admire kind of researcher or scientist at the World Bank. It's kind of you are doing research. In the meantime, your research is you have a very clear application kind of context in your mind, which is probably somehow different from like research, say here at Cornell, right? So in that case, for you, what do you see as our responsibilities and roles that researchers like you we can play in addressing this challenge, and especially what kind of specific products or product, I don't mean it's a computer or something, like products, it could be tools, or it could be guidelines, or it could be policy recommendation. What kind of key outcomes or outputs that you think the research community can focus on that will support the execution of the vision that you just laid out?
Well, there are many things that can be done, I think. And so it's true that I carry research, but I also commission a lot of research to universities, actually, to answer some specific problems, because it's not, we don't have the research capabilities at the World Bank than universities have. And usually when we're looking for specific expertise, that's where we go to universities. And so I think that universities can be of tremendous help by building decision support tools. The key challenge is to make it accessible to decision makers. And that's where I see my role also, is to be able to translate highly technical, complicated tools and thinking into actionable decisions. And I think there's a big vacuum here in the translation of the science into decisions. And that's, I'm going to come back to the whole robust decision-making story, but here the idea is to bring all the information that's necessary for the decision maker to make their decisions. What we don't want is for academia or for the modelers to tell us, oh, this is the optimal solution, this is what you have to do. Because in many cases there is no optimal solution. There is so much uncertainty, there are so many variables that enter the choice, that it's a political decision. It's about risk aversion, it's about preferences for some objectives rather than others. But I think that having quantified tools and quantified results that show the trade-offs to decision makers, so that then they can make a more informed decision, is really where we need more work.
That's beautiful.
So it's really in the way we use the tools that are developed that there's a need for more support.
So now you say that actually you mentioned like you commission some of the research actually to the universities. So from your organization's point of view, especially your division working in this area, what do you see as some top priority areas for research where you will see universities could play a role in helping you?
I think one is on systems modeling in general, especially transport systems, bringing in the users as well as the engineers into the model. Because right now we have models that optimize transport planning. They use some user information on traffic, etc., but they still don't tell you maybe which users you will favor with which decision. And especially on infrastructure resilience, a big question that comes up right now is how do we identify critical infrastructure and how do we prioritize decisions in this space? And the identification of critical infrastructure really depends on who is critical for.
The stakeholders.
The stakeholders.
Yes.
And maybe that bridge is critical for everyone, but probably this road is critical for hospitals, this road is critical for the trucking companies that need to reach the port. And having models that also incorporate the users to also help those decisions on investment prioritization would be really useful. We worked with a researcher for that report on infrastructure resilience on building a supply chain model on top of a transport network model to understand, okay, if that road is disrupted, which industry is impacted and what are the losses after a few days of disruption based on how many inventories the firms have, for example, all of these new sets of questions.
Yeah, that's right. It's kind of, I think that's critical. It's kind of when you think about the resilience and the impact of the failure of infrastructure, when you try to quantify that loss.
Yes.
Right? How do you quantify that loss function? Of course, I think that loss function can be very tricky, and also the elements you consider could actually kind of embed the inherited equity issues if you do not account for certain stakeholders. If they leave them out, right? So I think I'll come back to this kind of deep uncertainty and also resilience maybe after one or two more questions. But one thing I think I know you have this this environmental climate perspective. Like even though you are now looking at infrastructure, but you really want to, by solving or by changing some of the thinking and the practice in infrastructure, and you hope to accomplish the goals of environment and climate mitigation, right? So for that, I feel it's kind of from these kind of environmental goals, we're looking at things, but there are a lot of times we will find ourselves fighting an uphill battle because the general concept, perception, which could be wrong, I bet, but the general perception could be okay. Environmental regulation, environmental protection, it's kind of somehow, anyway, it'll end up as red in the balance sheet of a company.
It's costly.
Right? It's costly. So while we are working hard toward these directions, I want to know about, can you give some examples where you feel you have some success stories? In the meantime, in some cases, you were really frustrated. Because I want to see, by comparing the success versus frustration, that could actually illustrate to us, some of the key factors that we can look into to develop more successful stories rather than being frustrated.
I think a lot of the success stories come from studies where we did an economic analysis to show the economic benefits of environmental actions. So you were mentioning air pollution. We have a lot of evidence now that the cost of air pollution is extremely high for people's health. The economic impact is extremely high. And in China, for example, if you do a cost-benefit analysis of switching from coal to renewables, the highest benefits, more than even climate change mitigation, come from health benefits.
Wonderful.
And a lot of requests we have from governments actually, and especially from Ministry of Finance, is show us the economic benefits of doing all these environmental regulations.
And per buck.
Yes, exactly.
Yes.
And part of the problem is that some of those benefits are extremely difficult to quantify, or even sometimes when it's about avoided casualties, it's extremely difficult to put a number on someone's life. But some of these benefits we are able to quantify. And you were talking, for example, about the cost of infrastructure disruption. Well, if you can quantify the real cost of infrastructure disruptions, including on firms and households, then that's also a benefit that is taken into consideration when you're investing in more robust or resilient infrastructure systems. And you can justify much more easily your investments because you've shown that the avoided losses are so high. And one of the first studies that I did for the World Bank actually was on Colombo in Sri Lanka. It was so it wasn't climate change mitigation, it was a flood protection project. And Colombo has a lot of wetlands that is currently protecting them against flooding, but they're losing them because they have no regulation and there's a lot of encroachment and people don't understand the value of those wetlands. And so we did a study where we modeled the flood losses with and without those wetlands, also under future conditions with climate change. And we showed that the economic benefits of protecting the wetlands were higher than losing them in the majority of scenarios. And that had a big impact on the government. Because it's sad that you always need a number in dollars to convince people, but that's the reality. And so having economic models that also capture some of the benefits that we're talking about, I think is key.
I totally agree with you, and I think it's kind of, as you say, it's sad that we have to come up with numbers, but it's kind of when people really come into the decision making, and a lot of times people are making trade-offs.
Yeah.
And when you make trade-offs, you cannot base the trade-offs, on just ad hoc. You want to compare like the benefit-cost ratio.
Yeah.
So those things need to be quantified.
Yes.
And also, I think we were talking about this. I feel it seems like in a lot of these cases, it's not really the lacking of technology or even scientific research. It's really the lacking of the very effective communication,
yes,
right, to the decision makers as well as the general public behind those decision makers.
Yes.
Right. Yeah. I think that's exactly that. You say it's kind of how we translate all those different, outcomes into the losses and associate them hopefully with some monetary terms, and then compare that to, you say, if you lose that, wetland, this is, and if you keep this. Right, because otherwise, people are always like short-sighted.
Yes.
Right. So I think that's wonderful. So when you try to quantify this, I'm going to now gradually kind of shift the gear towards another area that I think you're working on, is basic infrastructure resilience. So we know that now this word resilience is really now a buzzword. It's
yes.
very hot, but I think probably for our audience. Do you want to give, your definition or your interpretation of what people mean by infrastructure resilience, such that, when they probably hear something later talk about this, this is what Julia means by resilience.
So it's a battle also internally within the World Bank. Now everything is called resilience. It's become almost a synonymous of good.
Yeah.
We have resilience, social development, anyways. But when I'm talking about resilient infrastructure, especially for this report that we just published, that's called Lifelines, we mean both risk reduction and the capacity to recover after a shock.
Yeah.
So it's both limiting, it's more robustness and resilience together that we call resilience.
Yes.
And we take it also broadly. It's not just the recovery of the asset, it's also the recovery of the overall system and of the users.
Mm-hmm.
So we have 3 levels of resilience in our framework, and we describe the 3 in the report.
So yeah, that's wonderful. Like you, as you mentioned, this Lifeline project, and also by the way, you have also had that wonderful book about Beyond the Gap.
Mm-hmm.
I think those are really very good readings. I clicked on the link and I read into that. Those are really very good. I think it's not only the analysis you did. It's really, I feel a lot of time it's really the how we can change the mindset
Mm-hmm.
of people. So now when you talk about this resilience, actually, because you've done a lot of work about robust planning or even robust optimization. It seems like robustness and resilience seem to be somehow again something that you can you have to trade off.
Yes.
While you can build this kind of infrastructure to be very robust, but that could be very costly.
Yes.
And turn out to be unnecessary.
Yes.
Right, but in the meantime, if you do not build it robust enough, it fails, right? And then there is a resilience issue,
Yeah.
right? So, for this, so what are for this kind of research that you are doing you are working on now? I want to see, and I see that your work has provided some very specific, concrete recommendations. Would you like to share with people about how we can? What are the very concrete, specific strategies or steps that we can carry out in building more resilient infrastructure systems?
Well, I think on the planning side of things,
Yes.
The main recommendations are identifying the critical assets
Mm-hmm.
within your system, but so this requires thinking about the overall system, right?
Mm-hmm.
Not just thinking at the level of each bridge or each road or each power plant, but thinking about how each asset plays out in the overall system and which ones are critical for which users, for whom.
Mm-hmm.
That would be the first step to prioritize budgets in those critical assets. And
Mm-hmm.
there's a whole need also for research on how we identify those critical assets and how we define them.
Yeah.
But then it's also, so that's more the robustness part of things. And then it's the whole resilience idea, because we know that we won't be able to prevent all disasters, even more with climate change now. I mean, this typhoon in Japan last week, a lot of people were surprised. They thought that they were protected by their infrastructure. And yet the infrastructure failed,
Mm-hmm.
and it had much higher damages than expected. So we need to recognize that we will have damages and shocks from which our infrastructure is not protecting us. And so that's where we need to build the resilience of the users. And so focusing also on critical services like hospitals, making sure that hospitals can still function even if the electricity grid is out, even if the transport system is interrupted, or if the water system is interrupted. And then same thing for the firms. Supply chain resilience, I think, is an area of research that is just beginning.
Mm-hmm.
There's a lot of research in Japan on this, and also some good papers on California. But in most other regions in the world, we don't have the firm data, and I've seen very few papers on supply chain resilience. And then finally, it's the households as well. And it's all the behavior science. How do you convince people that they need to have maybe 3 days of water in reserves in their house, and 3 days of food, to avoid that infrastructure disruption can become a disaster if they don't have that. But if they have enough supplies at home, then it's an inconvenience for a few days. And so it's also working a lot on the users, and I think on this there's much more that needs to be done, especially on the communication side.
Yes.
I mean, if I go back to the example of Japan, people didn't want to evacuate
Mm-hmm.
because they thought that the levees would protect them. And so it's convincing people that yes, they do have to evacuate. It's important.
I see. So I think this, of course, I think when you are trying to balance this robustness versus resilience, like of course, as researchers, right? Again, you're trying to quantify these things and you're trying to forecast. Okay, I think like thousands and of all these different scenarios, and then that will help help you with the decision making. But I was doing the online search about your recent work. I noticed that even you are able to simulate these thousands of scenarios, but there are still going to be black swans.
Yes.
So I noticed that you've been doing this kind of deep uncertainty. Do you want to speak a little about the work related to that area? This deep uncertainty work.
Yes. So this deep uncertainty work started during my PhD when I was working with integrated assessment models.
Mm-hmm.
Because those models produce scenarios for the IPCC without exploring the uncertainty around the assumptions they're making on technical change, on people's behavior. And so I was trying to push that community to recognize the deep uncertainty on a lot of the parameters of those models, mm-hmm. and look for more robust solutions. And I think at that time it was very difficult to convince them because those models are so big. Mm-hmm. No one had the computational capacity to run them in a systematic way with thousands of scenarios. Now it's changing. I think there's more and more computer capacity everywhere, and so that shouldn't be a constraint anymore. Mm-hmm. And I feel like that everyone working with a model that does simulations for more than 10 years or 20 years should be using those approaches, which is really recognizing the fact that we're not able to even come up with good probability distributions for most of our parameters. At least all the ones that are related to technical change and climate change impacts. And so taking the view that, okay, because we don't know the probability, we're going to explore all the scenarios that we can possibly think of, mm-hmm. and look for robustness in our decisions. And even then, I think you're right that there are black swans. And so even when we come up with a strategy that we think is the most robust based on the information we have, thinking maybe, okay, what it is that could make our strategy fail. And on this, there are lots of techniques where you bring experts from completely different disciplines to try to bring you a new point of view on your decision and tell them, what could go wrong in this context that maybe you haven't been thinking about. So it's not something you want to do for everything because it's a costly exercise. But I think that for big, expensive decisions that have long-term consequences, we should all be using those methods.
I don't say it's a good advice. I think it's really, a point of wisdom that you just offered, right? And when we're dealing with, these kind of huge infrastructure China investment decisions while facing, this much uncertainty. I think, the point you just made, it's really, I think it's a general wisdom that I think different layers of decision makers can hopefully adopt and use them. I saw that, we're running out of time, but I think this is really great. So
thank you.
Thank you, Julie.
Yes.
Yes.
Thank you.